So let's look at some examples of verifying trig identities. So just FYI, I broke down like different strategies for how to do this in my lessons video, and then in this video I just have a couple of random examples. I haven't planned anything in advance, so you're just going to hear how I reason through these without any, advanced thought to this. And just as a reminder, so I'm going to flash all the different identities that we have available to us for these particular exercises. So these are the identities that I'm going to use for these problems. Okay, so starting with A, so I see that I've got cosine of x over cotangent x times sine of x equals 1. This is obviously the more complicated side, so I think what I want to do here actually is I want to break this up into cosine x, sine x, and then 1 over cotangent x. And I'm doing that because I know that cosine of theta over sine of theta, this is cotangent of theta. So this is cotangent of x. And then I know with my reciprocal identities, I've talked about this in other videos, you've got cotangent of theta is equal to 1 over tangent of theta, and the opposite is true, meaning tangent of theta equals 1 over cotangent of theta. So I can use either one of those. So this is tangent x. Now there's a couple different ways that you can think about this. For one thing, cotangent x times tangent of x, I know that that equals 1 because, again, they are, reciprocals of one another. Tangent of x is sine of theta over cosine theta, and cotangent is cosine over sine. So I know by looking at this that this would equal 1, but if that is not satisfactory, again, you can always just write these in terms of sine and cosine. So whatever makes you most comfortable, more than one way to do this, but now I can definitely see, right, that this is just going to give me 1 equals 1. So we're good there. Okay, so starting with B, or going on to B, so I've got 1 over secant x minus tangent x equals secant x plus tangent x. Okay, so when I see a fraction that I can't simplify like this, to me, this is screaming to use the conjugate. So I am actually going to go ahead and just multiply by the conjugate, and I'm just going to see what happens. I don't know if that's going to give me something, but I have just done enough of these problems at this point that usually if there's a fraction I can't simplify, that's the way I want to go. So I'm just going to start with this, and I'm just going to focus on this side for right now, so I'm not going to worry about the other side. So let's go ahead and just multiply this all together. So this gives me secant x plus tangent x over secant squared x minus tangent squared x. And so secant squared x minus tangent squared x, well, that's going to be really relying on this Pythagorean identity, right? So secant squared x minus tangent squared x would just leave me with 1 if I rearrange those terms. So this equals 1. That's a Pythagorean identity. So then I'm left with secant x plus tangent x over 1, which just equals what I was trying to verify. Boom, verified. Okay, C here. So I've got 1 plus sine t over 1 minus sine t minus 1 minus sine t over 1 plus sine t equals 4 tangent t secant t. Okay, so again, just kind of going with just some basic principles. This side, to me, I feel like I just can't really do anything with it unless I get a common denominator, so I want to get a common denominator. I just want to combine these two fractions so I at least have a singular fraction. So if I do that, and again, if you are watching this because you are trying to get better with these, I've given you a big hint here. So I recommend that you pause the video and try to see if you can finish this one. And even if you get stuck, you will learn so much more from this if you try this first on your own and then watch. Okay, so I need to get my common denominator. So I'm going to multiply, let's see, I want to save space here. Let's see if I can save space. So I want to multiply this side times 1 plus sine t. So I have to multiply the top and the bottom by that. So this is what I'm going to do to this one. And then to this fraction, so let's see, I'll put parentheses around everything. So to this fraction, so I'm going to multiply, I need this to be 1 minus sine t, so I get that same denominator, so times 1 minus sine t, 1 minus sine t. Okay, so we got a bunch of stuff to work out here, so I'm going to go ahead and start multiplying stuff. So let's see, if I multiply this set of parentheses with this set of parentheses, that's going to leave me with 1 plus 2 sine t plus sine squared t. And then with this set of parentheses, so notice I'm putting another set of parentheses around them just to keep myself organized. So sine squared t, there's what that set's going to get me. And all of this is now over my denominator, 1 minus sine squared t. Okay, so now, let's see, I could use a Pythagorean identity at this point. So I feel like, you know, I could take 1 minus sine squared theta equals cosine squared theta. I know I have that available to me. And in some ways it feels like the bottom is screaming for me to use that, but I want to finish the top part here because I don't know what's going to happen here, so I'm actually just going to focus on simplifying the top first. So I see from kind of analyzing this, the 1's drop out, and then I'm going to have sine squared t minus sine squared t, so these drop out. And then let's see, I have 2 sine t minus sine 2 sine t. So actually the top will just become 4 sine t over this bottom part. And now my hunch was right. I do want to convert this bottom part into cosine squared. So this is going to become 4 sine t cosine squared t. Now notice, what we're trying to get this to equal to has nothing squared, so that's like a hint to me that I probably need to break up this squared term, okay? So this becomes 4 sine t, so let's break this over cosine t, and then let's break out the other cosine t. So you see how I broke that up? And now we're golden, right? Because this is tangent of t, not x, we're using t, and this is cosecant. So bada bing, bada boom. 4 tangent t, oops, I'm sorry, I said cosecant, I meant secant. Secant t, boom. And now for D, so I've got all these things, cosine theta minus sine theta times secant theta plus cosecant theta equals cotangent theta minus tangent theta. Okay, so this stuff just needs to be multiplied, so let's just do it. Let's just do it. I would recommend that you try to multiply this together. Again, math is not a spectator sport. I highly recommend if you're watching this because you are struggling with these that you try this, and then if you are stumbling, then hit play. Okay, so I've got cosine theta, secant theta, plus cosine theta, cosecant theta, minus sine theta, secant theta, minus sine theta, cosecant theta. So I'm just going to work on, this side. I'm just going to work on this side for right now, okay? All right, so, you know, I think that the next obvious thing to do, like just, you know, path of least resistance, would be to use the reciprocal identities, knowing what we know about secant and cosecant. So write everything in terms of sine and cosine. So I've got cosine theta times 1 over cosine theta plus cosine theta times 1 over sine theta minus sine theta times 1 over sine theta minus sine theta times 1, oops, this should have been cosine theta, and then this one is sine theta. Okay, there we go. All right, and so now I can see like these cancel out, so this will simplify to 1, as will this. So these two parts simplify to 1. So now I'm left with 1 plus cosine theta over sine theta minus sine theta over cosine theta minus 1. And okay, cool. So the 1's drop out. And so what are we left with? So cosine over sine, this is cotangent. And this is tangent. And wasn't that what I wanted? All of this equals cotangent theta minus tangent of theta. Boom, done. Always feels epic when you get it. At least it does for me. I know it can be really frustrating, but it always feels really great when you kind of figure it out. So like I said, there are more than one way to go about these. So if you have questions on it, you can always feel free to leave me a comment. Or if you want to see some more, you can always suggest some. I'm always taking suggestions from my viewers. And otherwise, thanks for watching, guys. I'll catch you next time.